All right, so welcome to Chapter 7 practice test. I'm going to go over how to work out each problem. If you missed one on your regular test, you can go back here, look at it, see how I work out the other problem, and see if that helps you on your test. So you may have to skip around if you need to. Number 1. So on number 1, we are going to be selecting the ordered pairs shown in the mapping diagram. So remember the input, that's my x's, and the output are my y's. So 2 goes to 9, so 2, 9. 4 also goes to 9. 6, 10. And the last one is 8, 11. Now, since each input only has one output, that is a function. Number 2, 18 to 1. So 18, 1. 32. 16 goes to 4. And 40 goes to 3. So those are the ordered pairs. And then if you look, each input only has one output. So that one is also a function. So an example of one that would not be a function is if you had let's see, 18, 1, and then you also had 18 going to 2. So for each input, you can only have it going to one output. If it goes to more than one output, then it'd be a no. All right, let's look at number 3. So this one right here is a good example. So see how 9 goes to 16 and 9 goes to 12? That means no, it is not a function. You cannot have an input going to two different outputs. So number 14 is okay because they all go to one output. All right. Number 5 says, which mapping diagram represents the relation? So we got to see which of those matches the graph. So -3 is at the 5. So we're looking for a -3 to 5. Good. This one we can get rid of because our input output arrow is going the wrong way. Same with this one. So this one right here doesn't even have -3 for an input. So I can tell you right away this is going to be my answer. Each one of these is right here on the graph. So when I said determine if it's a function, the answer is actually no, it is not a function. The reason it's a no is because right here, -1 has two different outputs. So you cannot have two different outputs at -1. So right here. Number 6, you need to write the function rule. So the output, remember the output is your y, is twice the input, which is your x. So y is equals twice the input means 2 times x. So you get y equals 2x. Number 7, graph the function. So what I like to do is the slope-intercept form. So remember it's y equals mx plus b. And then, so my m is the number in front of the x. Now this one, be careful because it's a minus 3x. So that's a -3 for your slope. The 1, that's your y-intercept. So I could have rewritten this y equals negative 3x plus 1, and then it would have been easier to graph. So my y-intercept is positive 1. My slope is negative 3. That means I go down 3 and over 1. So it's going to be right there. So once I connect those two dots, it'll make my line. On number 8, we're going to use this graph to write our function rule for the linear function. All right, so what we do is we've got to find our slope, our m. Our slope is up 1 and over 2. So we go up 1 over 2, so that's 1/2. And then our y-intercept is where it crosses the y-axis, which is at negative 1. So we get y equals 1/2 x minus 1. So that's one way to do number 8. Number 9, does the table represent a linear or nonlinear function? So for this one, what you have to do is figure out the pattern, okay? So this one we go plus 2, plus 2, plus 2. Down here, 8 to 0, that's minus 8, minus 8, minus 8. So since it does have a consistent pattern, that one would be linear. So it is linear, has a pattern, so we're good. Graph the function. So this one again, your m, your slope, is the negative 2. So negative 2 over 1. And your y-intercept is negative 3. So I go to negative 3 on my graph. That's my y-intercept. My slope is negative 2. So I go down 2 over 1. Well, I could go up 2 and left 1. Either way, the line's going down. That's negative. So there would be my graph. Okay, number 11. We want to know, does it represent a linear or nonlinear function? So we got to see, is there a pattern? 0 to 2, that's 2, adding 2, adding 2, adding 2. Here, negative 1, that's adding 0. And then this would be adding 8. And then something else. So that would be nonlinear. You're not doing a pattern. Write the function rule. So the output, that's your y, is equal. So we have y equals 2 less than 6 times your input. So 6 times your input would be 6x less than, that's going to be minus. So you have to do minus 2 for that one. You can't do 2 minus 6x. So we end up with y equals 6x minus 2. Number 13. Since this one has an x squared, because you have y minus 4x squared equals 3x. If we add 4x squared to both sides, you end up with y equals 4x squared plus 3x. Since there's an x squared, the answer is nonlinear. That will not be a straight line. Number 14, this is an easy one. That's a straight line, so that's linear. If it makes a straight line, it is linear. Number 15, the graph shows the distance traveled by a vehicle over time. Describe the change in the distance. So, if we look at the graph, it's increasing at a steady rate. So as the distance increases, the time is increasing. So that would be this first one right here. The distance increases at a constant rate for the entire time. 16. Use a graph to represent the relation shown in the mapping diagram. Then determine whether the relation is a function. So we got to do our ordered pairs. 1, 1, and 1, 4. So 1, 1, 1, 4, and then 2, 2, 3, 1, and 4, 3. So those are all those points. But you see how these 2 points right here hit both of them at the 1? You can't have the same input give you 2 different answers. So this one would end up being not a function. So if you do a line check, you do a vertical line all the way across. If it hits 2 points at one time, it is not a function. Could have told that also right there because the 1 hits 2 different numbers. All right, number 17, just graphing again. So our y-intercept, hopefully you're good at these. The y-intercept is 3, so I go up to the 3, put my first dot. My slope is negative 1/2. That means I'm going to go down 1 over 2. Or you could go up positive 1, but then you got to go left 2. And your graph would be right there. Number 18, the graph shows the temperature throughout the day in a city. Describe the change in temperature. So if you look at the temperature, starts up here, and then what happens? It gets colder. Then it stays constant for a little bit, and then all of a sudden it starts warming up. So we're looking for one that talks about how it first decreases at a rate, and then that could be the beginning of the day, it starts getting colder, colder. Then the temperature stays the same for a while, and then it increases at a constant rate for the rest of the day. So it'd be that last one. All right. So on this one, you got to match the graph with the story. So it says you are competing in a foot race. You begin the race by increasing your speed at a constant rate. So you're increasing the speed. That means it should be going up. Then you run. So let's draw a little thing as we read. So you're increasing. Then you run at a constant speed. So that means then you kind of even off. Until you get a cramp and you have to stop. So if you have to stop, you're going to end up going down. You're probably going to go down a little faster because you got a cramp. And you stop. And then, let's see. You have to wait until your cramp goes away. So you're waiting, not increasing. And then once it's gone, it says you start increasing your speed up at a constant rate again. So going up. I guess we start lower. So we're going to look for a graph that looks like that. So I would say it's going to be the second graph. And on number 20, graphing again, I like to do the y-intercept. The y-intercept is 3, so I go up to the 3. The slope is negative 5 over 1, so I go down 5 and right 1. And that would make my graph. So good luck on your test retake.